So we have been working with quadratics, and we have been taking two binomials and multiplying them together to get the simplified version. Up here, what I have is the simplified version of four different quadratics, and what we want to do is reverse the process that we learned last week. So we need to take this equation and turn it into its factors. And the reason why we want to do that is because if we have the factors, then we know the zeros. And so it's just a much more useful form for solving these equations. So we know that we are going to turn this into two binomials. We know that the first terms need to multiply to this. So that's going to be x times x. So that's nice and easy. We know that the last terms need to multiply to 6. So I'm going to just list them off. They could be 1 times 6, 2 times 3, and -1 times -6, and -2 times -3. Right? Those are the possibilities of two whole numbers that multiply to 6. But now to figure out which one of these four is the right answer, what we need to do is think about this middle term. And we always created this middle term by adding together the O and the I, the outsides and the insides. When these were multiplied together, plus these being multiplied together. That's what gave us that middle term. So that means one of these sets must add to 5. So 1 plus 6 is 7, so that's not it. 2 and 3, that makes 5. That's probably it. I shouldn't say probably. That's 100% it. But we'll just go through the rest of them just to look at them. -1 times -6 is -7, so that's not it. -2 times -3 is -5. We're looking for +5, so that's not it. So that means this is +2 and +3. +2, +3. That's how we're going to get our answer. So these two things multiplied together will give us this. And let's just check it. X times x is x squared. X times 3 is 3x. Plus x times 2 is 2x. 3x and 2x gives us the 5x, right? That's that middle term. 2 times 3 is 6. So we are all set. That is factored. So we need to do the same thing here with this. We know it's going to be binomials. We know that the first term's x. We're looking for two numbers that multiply to 12 that will add to -7. So some of you might be able to just go, oh, these are the answers. But if you don't, if you just start listing them. We have 1 times 12. We have -1 times -12. We have 2 times 6, and we have -2 times -6. And we have 3 times 4 and -3 times -4. I like to just start counting, go 1, 2, 3, and just see which ones line up. Now we're looking for two numbers that will add to -7. Well, 1 and 12, 13, that's -13. That's 8, that's -8. This is 7, but we're looking for -7, so that's it. And we have the answer. It wouldn't matter if I put -4 or -3 here. It doesn't matter which way it goes because in multiplying you can go in both directions. All right, let's try it one more time. So we again know we're looking for a binomial, and we know that the first terms are going to be x. And so we're looking for two numbers that multiply to -54 and add to +3. So let's just be a little bit more careful this time. So I'm going to start with 1, and I'm going to think of 1 times -54. And therefore, -1 times +54 is another one, right? So they're slightly different. 2 certainly can go into 54 because 54 is even, and that's going to be 27, well, -27. So therefore, -2 times +27 will also work. 3 can go into 54 because 5 plus 4 is 9, and we know the rule for that. So 3 can go into here, so 3 times, and it is going to be 18, so -18, and therefore -3 times +18. And then we think about 4. 4 doesn't go into 54 because 54 is not an election year, 1954. before. Anyway, 5 doesn't go in there because it's not 5 or 0. 6. 6 can go in there because I know 2 and 3 are multiples of 54, therefore 6 is 2. So we're going to do 6 times negative 9, and then we can do negative 6 times 9. And then we can look at 7 and 8. Nope, nope. And we know we're done because then the next number would be 9, and we'd be reversing this process. So one of these had better add to positive 3. This is going to be negative 54. Negative 53, positive 53, negative 25, positive 25, negative 15, positive 15, negative 3, positive 3. So we do minus 6 plus 9. That's a positive 9. All right. So those are the basic ones. Here's the harder one. It's only a little tiny bit harder. You'll notice that there's 2 variables in it. So we start out the same way. When we start looking at this term, we know it has to be x times an x. That's the only thing that's going to multiply to x squared. So now we're looking for 2 things that will multiply to y squared. And then we know we need a y here. So really, we're going to have to break this y up. So let's start listing off all the factors of negative 15. So negative 1 and 15y, because that's going to give us that. Negative 1y and 15y. So we'd have 1y times negative 15y. Okay? We could probably ignore the y at this point and just list and then remember to put it in at the end, but I'm going to do it all the way out anyway. 2 doesn't go into 15, but 3 certainly does. 3 times 3y times negative 5y and negative 3y times 5y. So we're done because 4 doesn't work, and then we have 5. So now we're looking for 2 of these things that when added together will give us negative 2y. Well, it's not this one, it's not this one, it's either this or this. Negative 2y is what I'm looking for, so that is going to be my answer. So I'll have plus 3y minus 5. And that's it. That's how we multiply these together. Thanks.